Algebra, know what a sliding rule is for. Well, I do know what it was too. This one could be with you. What a wonderful world this would be.
Good afternoon, everybody. Welcome to Mr. K's 30 Minutes of Math. I hope you are all doing well. It is windy outside today, so if you got a chance to go out there, I'm sure your hair got moved around quite a bit by the wind, and I hope you stay safe. All right, well, let's get started. I'm gonna turn the video off so we can focus on the work. All right, let's dive in with our riddle of the day. So this one was similar to one that we had before, but it focuses on triangles instead of squares. And it asks how many triangles are in the figure that we have here. And I'm curious if anybody was able to come up with a solution. If you did come up with a solution, go ahead and share it in the chat box. There are some that jump right out at you. So there's like this triangle right here, and then there's this one, and then this one, right? So those are sort of the obvious ones, and you can count those up. But I'm going to use a different marker for this. But then each side also has this one, and also this one, and also this one. So right there, that's 3 more for each side, and there's 5 sides, so there you go, 15 more. And then there's also these guys right here. Oh, I guess green wasn't the best for that. Let me use maybe black. This one, and then you have another one over here. So lots and lots of different options to get our triangles. So are you ready for the answer? There it is, my friends. 35 different options, 35 different ways to get triangles out of that diagram. Pretty incredible. For how to do, you just draw a pentagon, and then you just connect all of the corners. Wasn't the most beautiful pentagon in the world. It looks like somebody may have sat on it, but you get the idea. All right, let's move on to our work for the day. This was our homework from last night, and I think we did one last night. So let's just go ahead and do the second one. So we have 1 3/10 minus 7/10. I'm going to go ahead and create a number bond here. We know 1 is 10/10, and then we have 3 more tenths. So if we add that up, we get 13/10. So then I can do 13/10 minus 7/10. And if we have 13 and we take 7 away, we are left with 6/10. All right, that's not so bad. Let's keep going. And we see already some answers coming in. That is fantastic. Let's see what we have today. All right, so let's put this great fractions work to use. We have a few word problems. No problem for all of you guys. I know you're going to do a fantastic job. So let's see, number 1. I will highlight it as I go. Sue ran 9/10 of a mile on Monday and 7/10 of a mile on Tuesday. How many miles did Sue run in the 2 days? So 9/10 on Monday, 7/10 on Tuesday. All right, 9/10, and then she ran 7/10 more. So that is going to give us 16/10. And then we could do a number bond. 10/10 is part of it. That gives us 1 whole. And then we're going to have 6/10 left over. And remember, that's our whole. 1 6/10. Well done. And we have a number of folks writing in. Fantastic. All right. Number 2. I'm going to read it. Miss Salazar Mr. Salazar cut his son's birthday cake into 8 equal pieces. All right, Mr. Salazar, Mrs. Salazar, and the birthday boy each ate 1 piece of cake. What fraction of the cake was left over? All right, I see an answer there from Ezra 5/8. Let's try it out. First of all, we know we are dealing with 8 equal pieces, which means we are dealing with eighths. All right, and we're starting with a whole cake. So a whole cake would be 8/8. And then how many people eat a piece of cake? Mr. Salazar, Mrs. Salazar, and the birthday boy. So that would be 3 of them. So after they eat those 3/8, we will have 5/8 left. Very good, very good. All right, let's move on. Let's try a couple more. I'm going to ask you guys to work on these, and then we will be right back. Give them a try, and I'd like you to use the RDW method. Read, draw, and then write. Read, draw, and write. Okay, go ahead and take a few minutes to do that, and we will be right back, and I'll give you a little bit of music too. Okay, let's check back, and I see a few folks are already writing in. Let's see how it goes. So first we're going to read. Maria spent 4 cents of her money on a book and saved the rest. What fraction of her money did she save? So she spent 4/7 and she saved the rest. Well, this one is interesting because you have to think for a second, what did she start with? Well, she started with all of her money, however much she had. And all of her money, that means where she started is her whole. So if she started with 1 whole, that would be 7/7. And it doesn't matter how much she had. That's not the point. The point is she started with it all. So it's the whole. And then she spent 4/7. And therefore she is left with 3/7. Well done. I see a number of folks writing in. And then let's look at number 4. Mrs. Jones, we're going to read first, had 1 4/8 pizzas left after a party. So this is how much she had after the party. After giving some to Gary, she had 2/8. After giving some to Gary, she had 2/8 pizza left. What fraction of a pizza did she give Gary? So this is an interesting one. Really got to think. Mrs. Jones had 1 4/8 pizza after a party, and then she gave some to Gary, and after she gave some to Gary, she had 2/8 pizza left. So she started, whoops, let me go back. She had 1 4/8, and then she gave some away, and when she was done, she had 2/8 left. And the question is, how much did she give away? Well, let's look at our 1 4/8 first. Let's do our number bond. 1 whole would be 8/8. And then we have 4 more 8s. So that is 12/8. Whoops. I was about to write 18, but that's not right. 12/8. Okay, so you know what I'm going to do? I'm going to change this to 12/8. Okay, she had 12/8. She gave something away and she's left with 2/8. So what did she give away? Well, if I have 12 and I'm left with 2, I gave away 10/8. And we could do our number bond. 8/8 is 1 whole. And then I'd have 2/8 left over. So there you have it, 1 and 2/8. And we know that 2/8 is the same as 1/4. So you could also do it as 1 and 1/4. Well done, everybody. Well done. I'm going to give you guys a nice round of applause. I am very impressed. You guys are rocking it. All right, let's go to our math joke of the day, everybody. Who was the roundest knight at King Arthur's table? Who was the roundest knight at King Arthur's table? All right, everybody, welcome back. Anybody have any ideas? Who was the roundest knight at King Arthur's table? Are you ready? This one is a good one. Circumference. All right, circumference. Now, if that doesn't make a ton of sense to you, that is okay, but let's take a minute and remember some of the circle geometry that we have been talking about with lots of our math jokes. So let's point out a few things. First, let's talk about circumference, which is right here. Circumference is the distance all the way around the circle. So I'll draw it in this red line right there. So that's circumference. And it's spelled, as you can see, with a C like this, circumference. And the joke is that they did it like this, circumference. So it's kind of a little play on words. Circumference. Some of the other words that we know when we're talking about circles, the diameter, that's the distance right across the middle. That was kind of a chunky diameter. Let me do that one again. That was not my best. So here's the diameter. And the diameter can be any direction. It just has to go right through the middle, and it only goes from one side to the other. It doesn't extend beyond the circle. And then last important piece is a radius. A radius is just from the center to the edge. And I have a little question for you. A diameter is how many times a radius? A diameter is how many times a radius? Take a look at the drawings there. A diameter is how many times a radius? Is it 1 times, 2 times, 3 times, 4 times, 8 times? Ooh, I see an 8 times. All right, let's take a look. Let's draw our circle. All right, and let's say in green, I'll do my diameter. And in red, I'm going to do my radius. So a diameter is how many times a radius? I'm getting lots of 8s, but 8 is not correct. Take a look at it again. Green was my diameter, and red is my radius. Maybe you were talking about this one over here. Sorry, I just mean in general, a diameter, that's right, is twice. So a diameter equals 2 times the radius, because the radius is halfway across the circle. So if my radius of a circle is 5, what's the diameter? If my radius is 5, what's my diameter? Let's see if folks can figure that one out. If my radius is 5, what would my diameter be? And I see some folks writing in, that's right, 10, very good. I'm going to show you just a few more cool parts of a circle. We've talked about, let's highlight the ones we've talked about. So we talked about a diameter, and we talked about a radius. There's a couple of other cool ones. This is right here is a chord. A chord is a line segment that goes from one point of the circle. So I'll show you from this point over to another point on the circle, but it does not, well, if it goes to the center, it's called a diameter. When it doesn't go through, it's just a regular old chord. A secant right here goes through the circle, and a tangent right here just touches the outside edge of the circle. And then an arc is actually a part, one segment of the circle. So let me give you a few examples. Back to our pictures, remember these from yesterday? Let's see if folks can write in, what would this be? This red segment on the basketball hoop. What would that be? A diameter, a circumference, a radius, an arc? What do you guys think? Right here, the red part in the basketball hoop. Yeah, Henry wrote in, that's a lot of circle parts. That's true, Henry. Very good, yes, that is a radius. Let me draw another radius on our pizza. Though if you get your pizza and it comes with a blue radius, you might want to send it back. That looks a little strange. All right, what would this be on the clock? What would that be? The green line. What do you guys think? What would that be? The green line on the clock. All right, Ezra writes in the diameter. That's right, because it goes all the way from one side to the other and through the center. All right, what would this one be on the basketball hoop? This is a tricky one to see if you remember from the screen before. Just this part right here in yellow. Henry, very nice. Arc, that's right. Although we do spell it a little differently. We spell it A-R-C. This kind of arc, that's like Noah's Ark with all the animals. That's like a ship, a boat. So talking about circles, we're talking about A-R-C. All right, well done, guys. You guys are getting really excellent with your circle geometry, which is going to serve you well as you move on through math. Let me do a little bit more checking for understanding. If the radius of this pizza is 7 inches, remember that means inches, what is the diameter of that pizza? What is the diameter of that pizza? The radius is 7 inches. What would the diameter be? Let's see if folks can figure that one out. Oh, I see some coming in right now. 14 inches is correct because we would go all the way across for the diameter. So we would have another 7 inches, and 7 plus 7 is 14. Very good. Okay, well, let's go over to our clock. Let's say the diameter of the clock is 11 inches. So the diameter is 11 inches. What would the radius be? What would the radius of that clock be if the diameter is 11 inches? Let's see if folks can figure that one out. Remember, the diameter goes all the way across in green, and the radius only goes to the center. All right, fantastic, folks. Everybody is writing in 5.5 or 5.5. And we know that 5.5, we can split that up and do our number bond. We know that that would be 10 halves and 1/2, which is the same as 11 halves. Well done. I'm very impressed. Everybody, good job. All right, let's get back to our practice. I'd like you guys to go ahead and do numbers 5 and 6, and then we will be back. Go ahead. All right, welcome back, everybody. I see some answers coming in, very exciting. I really like number 5 because it talks about cornbread, and if my son Akiva's out there listening, he loves cornbread. Well, we have 2 pans of cornbread. I'm going to pretend, whoops, let me use this. I'm going to draw the cornbread pans. Let's say that's one pan, and that's another pan. And he served 1 1/4 pans. Well, let's show that. Let's just do a drawing real quick. We're talking about quarters. He served 1 1/4. Well, here's 1 and then 1/4. What fraction of a pan was left? Well, you guys got it. 3/4. These right here. We can also do that in another way. We know 2 wholes would be 4/4. That's 1 whole plus 4/4, which gives us 8/4. And he served 1 1/4, so minus 1 1/4. We'll do our number bond, 4/4 and 1/4, which is 5/4. So then 8/4 minus 5/4, voila, gives us 3/4. Very good, very, very good. All right, number 6, let's read it first. Marius combined 4/8 gallon of lemonade, 3/8 gallon cranberry juice, and 6/8 gallon of soda water to make punch for a party. How many gallons of punch did he make in all? All right, lemonade, we had 4/8, whoops. We had 4/8. Cranberry juice, let's use red for that, 3/8. And soda water, let's use blue for that, he had 6/8. So let's add this all up. 4/8 and 3/8 gives us 7/8. And then we have 6 more 8s. So that gives us a total of 13/8. And then we can do our number bond. 8/8 is 1 whole, and then we have 5/8 left. Sorry, that's a little bit not the most beautiful 8, which means we would have 1 5/8 total punch in all. Well done, everybody. I am extremely impressed. All right, let's go on to our last 2 before tonight's homework. Go ahead, take a minute and give it a try. Okay, welcome back, everybody. Let's try these two. First one, let's read it first. Mrs. Smith took her bird to the vet. Tweety weighed 1 3/10 pounds. The vet said that Tweety weighed 4/10 pounds more last year. How much did Tweety weigh last year? So right now, Tweety is 1 3/10 pounds, but last year, Tweety was 4/10 pounds more. Should we add these numbers, subtract them, or do something else? What do you guys think? Should we add, subtract? Oh, you guys are going straight to the answer. Holy moly. Well, let's see. Right now, Tweety is 1 3/10. And last year, Tweety was 4/10 more. So last year, Tweety was bigger, which means, ooh, interesting. We're saying subtract, but is it subtract? Because right now, Tweety is 1 3/10, but the vet said Tweety weighed 4/10 more last year. And we want to know, how much did Tweety weigh last year? So we're actually going to add these together. So 1 3/10, we can do our number bond. So there you have, this is 13/10 plus 4/10, which gives us a total of 17/10. And then we can do our number bond again. And we know that's 1 whole. So last year, Tweety was 1 7/10. And that should make sense, because if Tweety was 1 7/10 last year, and then lost 4/10 between last year and this year, that means Tweety would be 1 3/10 right now, and that's what the problem tells us. So you got to take a second to read it and really think about what it's saying. All right, let's look at number 2. Let me erase some of this so we can see better. Okay. Hudson picked 1 1/4 baskets of apples. So that's Hudson. Susie, let's do Susie in a different color so we don't get confused. Susie picked 2 baskets of apples. How many more baskets of apples did Susie pick than Hudson? How many more did Susie pick than Hudson? So Susie picked 2 baskets. Hudson picked 1 1/4 baskets. Question, how much more did Susie pick? Are we adding or subtracting here, folks? Adding or subtracting? If we want to know the difference between Susie and Hudson. Well, let's start with Susie. She picked more, 2 baskets. Oops, let me use my marker. 2 baskets. We know we're going to be talking about fourths from that fourth right there. So let's do our number bond. That would be 4 fourths and 4 more fourths. So Susie has 8 fourths. Hudson has, we know, 1 1/4. Let's do our number bond. 4 fourths, 1 4th. So Hudson has 5 fourths. All right, well, if we take away Hudson's amount, we'll know what the difference is. And you guys are absolutely right. It would give us 3 fourths. Excellent job, excellent job. Very impressed. Go ahead and take a screenshot of your homework for tonight, or take a picture or write it down. Isla walked 3/4 mile each way to and from school on Wednesday. How many miles did Isla walk that day? And number 2, Zach spent 1/3 hour reading on Friday. 1 2/3 hours reading on Saturday. How much more time did he read on Saturday than on Friday? And finally, our riddle to send you home. This one is really a head scratcher. You have an 8-gallon jug filled with water. So I'm going to draw the 8-gallon jug over here. Let's say it's like this. And it's filled up with water. And then you have an empty 3-gallon jug right here and an empty 5-gallon jug right there. Using only these materials, how can you measure exactly 4 gallons? So you can pour the water in between the jugs, you can pour water out, whatever you want, but you can only use these materials. Your 8-gallon jug of water, your 3-gallon empty, and your 5-gallon empty. So take a picture, write it down, see if you can remember that and work it out this weekend. Talk to your friends, talk to your family members, see if you can figure it out. All right, everybody, it was great to see you all. I had a great time today, and I hope you have a wonderful weekend and enjoy the weather. Take care, everybody. Bye.